Hello everyone, welcome to the second part of our triangle similarity conversation. So far when we talked about similarity, we've talked a lot about side ratios, we talked about how the angles have to be the same, but we've been talking about similarity kind of in general, and we said that this is true for any shape, right? All your side ratios should be the same, all your angles should be the same. In this part of our unit, we want to talk specifically about triangles, and I want to bring you back to when we did triangle congruency, and we had those 4 theorems, well technically 5 because we had HL, but if you remember we had those 4 theorems that involved sides and angles, right? We had side, 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 angle, side, angle, side, angle, and angle, angle, side. Remember those guys? We did all the card sorts. Okay. We're bringing that back, but now we're doing it for similarity. So when we talk about similarity, if you have an angle pair, we're looking for them to be congruent in the same way that we were with congruency. But now that it's similarity, I don't need, nor do I want, my sides to be congruent. Now I'm looking for them to be proportional. And if I can have, and what I'm looking to do, is prove that some triangles are similar. So on the Schoology assignment, that's one of the things that we talked about, where you had to find all 3 side ratios. And okay, now that you see all 3 side ratios, are those triangles similar? Because we tested all 3 and we know that's the definition of similarity, that if all of the side ratios are the same, then we know it's similar. Now, what we want to talk about today is, are there any other ways to tell? So we know if we have all the angles, that's enough. We know if we have all the side proportions, that's enough. But is there any other way to prove that 2 triangles are similar? Okay, if I don't have all that information. And the answer is, really, kind of only one way, but whatever. All right, so we have 3 theorems for triangle similarity, not 5 like we had for congruency. The first one we call AA, and this little symbol right here is read similarity, right? It's just the congruency sign without the equal underneath. So this is read angle, angle, similarity. And what it says is, if you have 2 angle pairs the same, then you're good to go. You have similarity. Okay, now why only 2 angle pairs? Let's think about that. So look at this example. I have the 75 that matches, and I have this 31 that matches. And this theorem is telling me that's enough. You only need 2, doesn't matter. But we said, well, wait a minute, I thought all the angles had to be congruent for similarity. And that's true. But listen, if these 2 are the same, this third one doesn't have a choice. Right? If I want to, I can go out of my way and figure out what that third angle is, right? There's 180 degrees in a triangle. Take away the 75, take away the 31, that leaves me with 74 degrees up here. I could do the same thing over here, but it's the same stinking calculation. I start with 180 degrees in a triangle, take away the 75, take away the 31 to see what's left. These both have to be 74. I don't need to calculate the third angle. If 2 of the angles are congruent, the third one's coming along with it. It doesn't have a choice. So all you need is 2 angle congruencies, 2 pairs, and you've got similarity. Okay? So here's another example. Now in this example, notice there's no numbers here. There's just angles marked. So when you first glance at this, you might be like, there's not nearly enough information here. Yeah, there is. Look. Here's a pair of angles right here. And my best buddies, the vertical angles in the middle. We've got 2 angle pairs. We've got angle, angle, similarity. Those 2 triangles are similar. And we could write a similarity statement, right? I could say triangle VXW, so from purple to green to not marked, is similar to triangle, let's go purple to green to not marked, so YXZ. YXZ. We want to make sure that we write it so that our angles are lined up, right? Our 2 purple angles have to be in the same spot. Our 2 green angles have to be in the same spot. Okay. All I need is 2 angles. Don't even have to worry about the third. And you've got triangle similarity. Okay, so the next way, the second one. The second one is the one we already know. We call it side, side, side similarity. We've known this. This is the definition of similarity. If you can prove that all three pairs of corresponding sides are proportional, have the same scale factor, then you've proven that the triangles are similar, right? So we've been doing this one. So if you pair up your sides down here, so 5 got multiplied by 2, right? To turn into 10. Let's see what happened. 4 turned into 8. That's times 2. It's looking promising. 3 turned into 6. That's also times 2. We have a scale factor of 2. I've proven all three sides have that same scale factor. These are similar. So again, I could say triangle, let's see, QPR is similar to its friend over here, and we make sure we list them in the right order. If I went QPR, TSU. 3 ratios the same, similar triangles. Okay, here's another example. Oh, I'm going to have to get my calculator for this one. All right, so just to make sure it hasn't been turned, I like to, especially when it looks like this one, it's pretty obvious it hasn't been turned. This one, I'm not so sure. So I like to look at the sizes. So on this side, the biggest is 35. So I'm going to go over here and find the biggest side. That's 28, right? So 35 and 28 go together. So my first side ratio is 35 over 28. And then I'm going to go find, my littlest side, which over here is 30 and over here is 24. So I guess they weren't turned, right? So my next side ratio is 30 over 24. And last but not least, my middle, so 32 became 25. So my last is 32 over 25. Now I don't know about you, but I need a calculator to see if these are the same. Right? 35 over 28 is 1.25. Okay, 30 over 24 is 1.25. That's good news. Okay, and last but not least, 32 over 25 is 1.28. Close. No cigar. Not similar. Sorry. All three side ratios don't match. I have to have all of them. If I have all of them, like over here, they're similar by side, side, side similarity. If I don't, sorry, not similar. Okay, last one. This is the only one that's really kind of new to us. It's the only one that we didn't already know, right? Is the side angle side. So this is like back to one of our favorite congruency theorems, and it's very similar. Notice side angle side, and what they're telling us here is you have to have the included angle. So remember all that business where it had to be the angle that was between the two sides? Same thing now. So this is kind of neat because this is the only kind of combination one we have. You can have all the angles, but you only really need two. You can have all the side proportions, or you can have a combination. If you only have two sides, two side proportions that match, if you can get the angle between them, then you have similarity. So let's take a look at some examples of this one. Okay, so let's look at the information we have because it's important to make sure you have the right stuff, right? So I have this side right here of 8 matches to this side right here of 6. So I have a side proportion of 8 over 6. I have this side right here of 20 going with this side right here of 15. So I have another side ratio of 15. I need to make sure these are the same before I go any further. So 8 divided by 6 is 1.3 repeating. 20 divided by 15 is 1.3 repeating. Okay, so far so good. I've got my two sides. The question is, do I have the angle in between? And so if you look up here at the very spot where the purple side and the blue side come together, sure enough, that angle is marked for us, and we have the angle. So these are similar by side, angle, side. I have two side ratios. Again, they're not congruent, but their ratios are good. They match, and I have the side angle, the angle in between. Okay, another one like this. I love these. Okay, so check this out. This is kind of a different way to do a problem. It's like they stuck a triangle inside of a triangle, and it hides some information. Do you remember when we did congruency and we had those shared sides? So we would have like a triangle that looked like this, and then it was split down the middle. And we said, well, this side is two sides really, right? It's the right side of this triangle, it's the left side of the other triangle. Okay, shared side. These have a shared angle. So this is what I want you to see. There's two triangles in this picture. There's the big outer triangle, of course, right? It has a side of 25 and a side of 21. But inside of it, there's this little triangle here, and it has a side 15 and a side 12. But notice they share this angle right here. They both have angle A, is that point right there. So I know I have an angle. It's got to be the same. Both triangles are using it. The only question is what's going on with my side ratios, right? So on this side, I've got 25 for my big triangle and 15 for my little triangle. So 25, oh, here goes my pen. Acting up. So I have 25 over 15, right? Over here, on the other side, I've got a 21 and a 12. So 21 over 12. I know I have the angle in between. That's a given. The question is, do I have the side ratios? Are these going to be good enough? Are they congruent or not? 25 over 12. Not congruent, I'm sorry. Are they the same? So 2.083 repeating. I want you to notice I'm not rounding these decimals at all. It's exactly what my calculator gave me. Over here, 21 divided by 12 is 1.75. Boo. Right. I have a side pair, I have a side pair, I have the angle in between, but the ratios aren't the same. So it doesn't work. They're not similar. Side ratios don't match up. Okay. So these are the only three ways that we can prove two triangles are similar. And again, from the last couple days, we've already learned that if you know the angles that they're similar, and if you know the side ratios, they're similar. So the only new thing right now is this idea of shortcutting it with side, angle, side. All right, so we're going to take a look at a couple pairs of triangles. I want you to tell me if you think they're similar, and if so, by which theorem. Let's go. All right, here's a pair of triangles. Mark the information. Try to figure out if you think they are similar, and if so, by what theorem. All right, you get it? Okay, at first glance, I think, I don't know about this. This has a 39, this has a 51. But in order to really look at this, we're going to have to figure out what this third angle is. Okay, so in this triangle, I have 90 and 39. So that's 129 degrees. So if I want to figure out what this third is, I just have to take that off of 180, right? So that's 51. Uh-oh. There's a 51 over there. I got it. Look, here's a pair of angles. And then don't forget about our best friends, the right angles. That's it, right there. Angle, angle, similarity. Now, if I want to be a show-off, I can come over here and say, oh, well, you know what? I'm going to figure out what this angle is. Okay, so this is 90 and 51 over here. So that's what, 141? So if I take 141 off of 180, that leaves me 39 for this angle. So I also have my third pair, but we already knew that, right? All you need is two. If you can show that you have two pairs, you've got angle-angle congruency, you're good to go. All right, let's take a look at another one. Okay. Oh, yes. A triangle inside a triangle. Okay, before you take off on this one, remember you've got this big outer triangle and then this little triangle sitting inside of it. They've got a shared angle right down here at L. Okay, see what you got. All right, let's see. All right. So I have this big outer triangle, right? Now, they didn't give us, like they did in that last one, they didn't give us the side lengths, but that's okay. I know that this whole thing must be 27 and 7 put together, so 34, right? Okay, and then over here, this whole length must be 30 and 9, so that's 39. Right. It's kind of mean of them not to give us the whole measurement, but that's fine, I'm over it, I'll add. Okay, then we have this little triangle sitting inside the big triangle, right? And I know its sides, they're 30 and 27. I also know that I have this shared angle here. So I'm thinking it's going to be this guy, right? Side ratio, angle, side ratio. I just got to check these ratios and make sure I'm good to go. All right, so if I do big to little over here, that's 39 to 30. If I do big to little over here, that's 34 to 27. Off to our calculators we go. 39 divided by 30 is 1.3. Not even 1.3 repeating, just 1.3. Okay. And then 34 over 27 is disappointing. 1.259, blah, blah, blah. Close. Not it. They have to match. If they don't match, we don't have it. So those aren't similar. Sorry. Don't worry, I have another one. Take a look, see what you think. Okay, let's see here. I'm going to pair up big side with big side. Right? So over here, my biggest side is 16. Over here, my biggest side is 10. So I have a ratio of 16 to 10. And that's going to be 1.6, so we divide it out. Okay. Little side, 5 with little side, 3. So 5 to 3. If you take 5 divided by 3, you get 1.6 repeating. So 1.6666666. Bad news. They just don't match. I don't need to check the third one because everything's already ruined, but I'll do it anyway. Right. 12 to 7. Is, boy, they weren't playing with this one, huh? This one is 1.714. None of them match. So I was hopeful I could use side, 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 but it's not going to work because my ratios don't match. They're not similar. Sad face. Well, he looks more than sad. All right, let's do one more. Okay. Oh, another one inside. All right. Well, this is an interesting one. Okay, have at it. Okay, let's see what we've got here. So we have two triangles, right? I'm going to try to be careful with how I color them. So there's the big triangle that goes around the outside, right? The big outer triangle. That triangle has this 67-degree angle in it, and it has this 25-degree angle in it. It has this angle up here, too. I don't know what that angle is, but I can figure it out, right? I think I will. Okay, so if this is 67 and this is 25, that's 92, which I should have done without my calculator. Shame on me. And then to figure out that top angle, 180 minus 92. So 180 minus 90 would be 90. And then two more would be 88. So this angle up here is 88. It's not looking good, is it? I see a 91 down here. All right, let's see. see what we got. Who knows? Maybe there's a triangle miracle coming. All right, so there's my outer triangle that's orange. Now, this line comes through the middle here, and it creates another smaller triangle that's sitting inside of the big triangle. It has 3 angles too, right? It shares, whoops. It shares this 67-degree angle with the orange triangle. It has this 91 up here. And it has this one down here, and we don't know how big it is, right? But we can find out. I don't know that we need to, but we can find out, right? I'm saying I don't know that we need to because the fact is I have the 67 shared. The 88 and the 91 are partners, and they're not equal. So I'm already dead in the water, but let's do it anyway just for fun. Okay, if this triangle has a 91 and a 67, that's 158. So 180 minus 158 is 28. So this guy, no, I'm sorry, goodness gracious, I can't add to save my life. 22. So this is 22. So look, they have exactly one angle pair. They share that 67-degree angle, and that's it. Fort Pitt, as my mom would say. Look, this guy is 3 degrees smaller, and then it took those 3 degrees and pushed them up here. So there's a 3-degree difference here. There's a 3-degree difference here. I have one angle, but I don't have a second. So I have to say not similar. Sorry. I know you really wanted them to be similar. Okay, so let's do this one more. Let's just go for it. I mean, the computer flipped forward already. Let's do it. Go ahead. Okay, so let's see what we got here. I spy with my little eye vertical angles. So I know I have an angle pair. Jackpot there, right? I definitely have an angle pair, so it's either going to be this one or this one. Okay. Now notice I have 2 side pairs. Right? So this is the one I'm going for. I'm hoping it's going to be this one. So let's get our side pairs going. Again, we don't really have the triangle names given to us, but that's okay because in this triangle I have big side, little side, and in this triangle I have big side, little side. So I know that the 48, which is the big side here, has to go with the 12, which is the big side here. So I have a ratio of 48 over 12, which is 4. Then I can do the same thing the other sides. So 24 here and 6 here. It's looking good. 24 over 6 is 4. So I have ratios that match. In other words, same scale factor. And I have the angle in between. So we can say these are similar by side, angle, side. Smiley face. Look at that. The bell, it's like timing. Okay. Any questions that you have about proving triangles similar, not congruent, put in the end of the video, and we will do some more practice. See you soon.